Hello, I'm Andrei Galichin, and today I would like to share my research on understanding how large language models actually reason. Recent AI models like DeepSeek R1, OpenAI's O1 solve complex problems by generating long chains of thought before providing the final answer. But how are these reasoning processes actually encoded inside such models? Previous research suggests meaningful concepts exist as linear representations inside a model's activation space. But finding these directions can be quite challenging. And to solve this, the researchers introduced Sparse Autoencoders, an architecture that comes as an efficient approach to decompose activations of large language models into interpretable features. But even if we use them, there is still thousands of them learned. So how do you find those that are responsible in particular to reasoning capabilities? In our project, I have covered all the bases. We discovered that reasoning models use vocabulary similar to human reasoning. They use words like alternatively, wait, maybe, and others. So we hypothesized that these patterns actually correspond to the model internal reasoning mechanisms. So, in our work, we trained a sparse autoencoder with approximately 65,000 features on the activations of the DeepSeek R1 reasoning model, and also introduced a reason score, a particular metric identifying features that activate exclusively on our defined reasoning vocabulary. Using this metric, we identified 46 features corresponding to uncertainty, explanations, and reflection, the specific human-like patterns they use when they do some heavy reasoning. But interpretation alone isn't enough. We need some causal evidence that these features are related to reasoning capabilities of the model and drive these capabilities. To validate this, we conducted feature steering experiments. By amplifying specific features during model generation, we achieved approximately 10% accuracy improvement on hard Olympiad mathematics problems and also increased the reasoning length of the model outputs by approximately 20%. So we believe that our work provides the first mechanistic evidence that interpretable components inside these large language models are causally linked to reasoning behaviors, and that we can manipulate them to enhance their performance. Thank you for listening.